On the battlefields of eastern Ukraine, Russian forces have a deadly new threat to contend with. The threat doesn't need food, water, or even oxygen, doesn't bleed when hit, doesn't sleep, and can't be intimidated or scared. And the threat grows in number every day. The threat is Ukraine's robot army, and it's hunting Russian soldiers relentlessly. As the fourth year of the war in Ukraine draws to a close, Ukraine's unmanned military systems are wreaking death and destruction on Russian forces from the air and the sea. But now, on the scorched battlefields of eastern Ukraine, unmanned ground vehicles, or UGVs, are becoming an increasingly prominent and influential component of Ukraine's military operations. So here's how Ukraine is integrating UGVs into its military and why it's making a decisive difference in Ukraine and likely far beyond. Military commanders have long salivated over the prospect of having an unmanned army at their disposal. The benefits speak for themselves. Unmanned systems are an ideal solution whenever particular operations make it too inconvenient, dangerous, expensive, or impossible to use human operators. Tasks like delivery of ammunition and supplies to frontline positions under heavy fire, evacuation of the dead and wounded, reconnaissance, and mine-laying have always been extremely dangerous for humans. And that's especially true on the battlefields of eastern Ukraine, where ubiquitous kamikaze drones flying overhead make any movement at all a potentially life-threatening action. For Ukraine, UGVs also present a feasible and affordable way of plugging the gaps on the front lines caused by a serious shortage of manpower. As a recent New York Times article's headline starkly summed up, Ukraine can't defend the entire front. Russia is finding the gaps. UGVs offer Ukraine a unique way of filling the holes and giving the Russian army a new bunch of headaches to boot. Alongside prodigious use of UAVs, unmanned aerial vehicles, and UUVs, unmanned underwater vehicles, both Russia and Ukraine have been experimenting with UGVs since the early stages of the war. But in Ukraine, their use really picked up after the establishment of the Unmanned Systems Forces, or USF, in February 2024. The USF is the world's first dedicated military branch focused exclusively on unmanned systems across air, land, and sea domains. According to their website, during January 2026 alone, the USF was responsible for hitting 27,762 targets, destroying 10,216 of them, killing 4,885 Russian troops, and wounding another 4,496. The majority of this destruction was inflicted by UAVs, but UGVs are steadily taking a growing share as the quantity and diversity of their use expands. Initially, Ukraine primarily used UGVs for logistics and medical evacuations, accumulating some 15,000 UGV systems of various types by the end of 2025. These systems are now handling an increasing percentage of Ukraine's frontline logistics requirements. According to Yuri Poritsky, CEO of DevDroid, a Ukrainian company that develops UGVs and combat modules, much like with kamikaze drones, initial skepticism towards UGVs has given way to calls of "I want that too." Early on, UGVs were the butt of jokes among Ukrainian soldiers. As the robots moved so slowly, they were passed by pickup trucks again and again. But that was before Russia's elite drone division, Rubicon, entered the fray, in particular targeting the fleet of pickup trucks Ukraine commonly uses to deliver supplies to the front. As the slow-moving UGVs trundled past the shells of burnt-out pickups on their way to successfully deliver supplies, attitudes changed. And now, as Poritsky puts it, everyone wants a UGV. No one wants to carry ammunition in a pickup that could be the next target for FPV drones. Today, Ukraine has a variety of logistics-focused UGVs in service. The Termit, for example, is a tracked UGV with a low-profile design for off-road mobility. It can carry loads of up to 440 pounds, has a range of 12 hours or 50 miles, and is resistant to jamming, a critical factor on the electronic warfare-soaked front lines. The Muraka is another of Ukraine's leading tracked UGVs for load capacity and battlefield resilience. It can reportedly carry more than 1,100 pounds of payload for dozens of miles, particularly in mined and artillery-heavy zones, and also features multi-channel communication to resist jamming. Even larger and more robust is the Protector. Designed as a frontline logistical workhorse, it can carry up to 2,650 pounds of heavy logistics like ammunition, mortar systems, and construction materials. With a diesel-powered engine and wheeled 4x4 chassis, it can ford water up to 3.3 feet deep and move it up to 40 miles per hour. As we'll discover a bit later, it can also pack serious firepower. Now, deep dives into innovative military technology like Ukraine's UGVs are exactly what we do best here on the Military Show. If you want to stay on the pulse of what's happening and why in military affairs, click that subscribe button. You'll be very glad you did. And speaking of Ukraine's UGVs, in addition to these domestically produced systems, Ukraine also has UGVs supplied by partner nations in service. Estonia, for example, has supplied at least 150 of the Themis UGV system, produced by Milrem Robotics and provided with the assistance of Dutch funding. The payload varies depending on the configuration, with a maximum of around 1,650 pounds. Both the Termit and Themis are also used for medical evacuations, alongside UGVs more specialized for the task. These include the Maul, developed by the first separate medical battalion for high-speed armored evacuation under fire. Capable of traveling at up to 44 miles per hour, it's reportedly successfully evacuated wounded troops despite mine strikes and drone attacks. These and other UGV systems have undeniably made a difference in saving lives on the battlefield. On the one hand, they keep troops in the fight, even in the middle of kill zones, by keeping them stocked with essential supplies and helping to get the wounded to the treatment they need in a timely manner. On the other hand, they reduce the risk to humans who would have had to perform these tasks in the absence of robots. But the real innovation and greatest value to Ukraine is in the increasing use of UGVs for actual combat operations, as robotic soldiers, machine guns, landmine layers, and artillery. The key demand from frontline troops is to replace the riflemen in the trenches, especially for the highest risk operations. Take, for example, using an Mk-19 grenade launcher, a common Ukrainian weapon on the front lines. First, the launcher must be dismantled and hauled, along with ammunition, to the firing position. It's a slow and dangerous task, as the group hauling the launcher can easily be detected by Russian drones and wiped out along the way. An Mk-19 toting UGV eliminates that exposure, effortlessly transporting everything at once and arriving ready to fight. UGVs could also be decisive in countering the current Russian tactics of pushing forward in large numbers, but split into small groups to probe for gaps in Ukraine's defenses and spread out its limited infantry defenses. Speed is the decisive factor in countering them, requiring Ukrainian forces to hastily take up new positions. These new positions require camouflage before they can be effectively manned, but that takes time, slowing down reaction speed and putting soldiers at risk of drone attacks while the camo is being strung up. An armed UGV, on the other hand, can open fire instantly, and even if it's hit, its operator remains unharmed, as they're controlling the UGV from a relatively safe distance. But despite all that tech, there's one major shortcoming with UGVs. The challenge is making robots that are able to fight even roughly on a par with infantry. No easy feat, but one that Ukrainian engineers are busy tackling. It's a work in progress, with ongoing trials and modifications to improve performance based on battlefield experience. Just 5 out of 13 manufacturers passed a recent live-fire test run by Ukraine's 3rd Assault Brigade and the Snake Island Institute. Despite these challenges, however, some models are already in active combat and delivering consistent results. And through direct cooperation with the military, developers are refining the platforms and equipping them to handle new weapons. So, what kinds of weapons are being installed onto UGVs, and what are the challenges in mounting them? At present, the most common weapons used in UGVs are large-caliber machine guns. Here, according to Poritsky, the main challenge is preserving the weapon's original design. To work effectively, the platform must be designed so that the machine gun works without any modifications. In its basic configuration, engineers used transition brackets to secure the machine gun without affecting the UGV's body, enabling quick weapon changes on the module. The only mechanical modification is the addition of an electric trigger to allow remote operation, while the gun's turret is controlled by electric motors and actuators. In advanced configurations, specialized software transforms an ordinary machine gun into a high-precision weapon. Developers tailor ballistic calculations for each system, according for distance, ammunition type, wind, and the target's angular velocity. Ammunition is also tracked automatically, so operators always know how many rounds are left. This software also makes use of AI-powered modules that identify enemies using movement and heat signatures. These modules can track targets independently, but firing is controlled by a human to avoid friendly fire. As the commander of the NC-13 UGV company in the 3rd Assault Brigade, identified with the call sign Makar, told the Ukrainska Pravda website, "We employ artificial intelligence in combat modules and machine vision to support patrolling and target spotting. Once a sector or angle is set, the turret patrols automatically. When it detects a moving object or heat signature, it begins tracking and alerts the operator. Look, someone is coming." These auxiliary features are already proving useful to operators. AI also helps to offset the limitations of unreliable signals for controlling the UGVs. According to the commander of the combined UGV unit at the Kartya unit, 2nd Corps of Ukraine's National Guard, identified as Matematik, electronic communication with UGVs is one of the main limitations of the technology, along with mechanics. The mechanical operation of the gun presents issues that, at this point, AI can't fix. A jammed round, for example, needs a human to unjam it, rendering the UGV useless until that happens. Although engineers have begun installing remote reloading systems on some Ukrainian UGVs to reduce the risk, for now, meticulous weapon preparation before combat is the only solution for the rest. As for the machine gun itself, the choice is largely driven by ammunition availability. The most common choice is the US-made Browning M2 chambered for .5 BMG ammunition. These are regularly supplied by Kyiv's partners, to the point they're more prevalent among the Ukrainian armed forces than the stockpiles of Soviet-era alternatives that Ukraine inherited at independence. Although the heavy caliber of the M2 requires a reinforced turret and stiff dampers to cope with recoil, it's valued for its range and armor penetration. However, when these 12.7mm weapons are in short supply, Ukraine has also taken to mounting 7.62mm machine guns such as the Russian PKM or Belgian M240. Ukraine also sometimes uses tank-mounted Russian PKMTs, which are often salvaged from damaged armored vehicles. In addition to the destructive power these heavy machine guns can inflict, they also have significant psychological impact on Russia's frontline forces. Poritsky sums it up. When the enemy hears a large-caliber machine gun, they immediately think heavy equipment is nearby. They realize that no ordinary soldier could carry a 50-kilogram gun. If enemy units are hiding in the buildings, they get very uneasy. They're aware that they will eventually be wiped out and they need to flee. On intercepts, our fighters even heard the enemy report, "Large armored vehicles are engaging us," when in fact it was only a camouflaged ground robot systematically hitting targets. As noted earlier, automatic grenade launchers are another weapon system ideally suited for UGV use. Unlike machine guns, they can engage targets from covered positions, firing overhead and beyond their direct line of sight. However, integrating grenade launchers is more complex than mounting machine guns due to their weight and recoil. The US-made Mk-19 weighs 77.6 pounds, nearly double the Soviet AGS-17's 68 pounds. The recoil from such heavy launchers can destabilize lighter platforms, so UGVs that wield them require powerful electric motors and actuators. Moreover, firing on the move requires stabilization systems to compensate for vibration. And according to Makar, no automatic grenade launcher modules currently on the market have this capability. And it's not just the physics of the UGV that gives it an edge. The software used in Ukrainian grenade launcher turrets also gives them certain advantages over human-operated launchers. Software, like the commonly used Wally 40 module, reacts faster than a human operator, automatically calculating the angle of barrel elevation needed to hit a target. Makar says, "The turret can be positioned in a forested area or in open terrain, while the soldier remains under cover and controls it remotely. For grenade launchers, the system lets you memorize between 10 and 15 targets. You can set the boundaries of a forested area, and if there's infantry moving there, the turret will independently engage targets across that zone in a zigzag pattern. This really simplifies targeting. Once the turret is in position, you enter the coordinates and it locks onto the target in a split second and fires accurately." Because UGV operators can't see a beyond line of sight target directly, the platform and turret rely on a complex system of 4 to 5 sensors, including compasses, gyroscopes, and GPS antennas. If GPS is jammed, the system picks it up and switches to alternative methods for determining its position. However, there are still a couple of serious issues to overcome. Similar to machine guns, the ammunition feed is the most mechanically complex unit on grenade-launching UGVs, and there are currently no widely available technologies for the automatic replacement of grenade boxes. That means sending humans in on dangerous repair or UGV extraction missions if the feed jams. Vibration is also a problem, even on larger platforms that can withstand the weight and recoil of heavy grenade launchers. Vibrations loosen bolts and damage electronics. So, after every mission, crews have to inspect the equipment and meticulously secure all connections. But besides these technical issues, which Ukrainian engineers are steadily overcoming, arguably the biggest challenge facing Ukraine with regard to implementing combat UGVs at scale is tactics. In essence, coordinating operations with unmanned forces, either alone or in combination with human forces, is a very different beast from coordinating human-only attacks. And Ukraine is compelled to work it out in real time in the field. Although the first experiments with unmanned, remotely controlled systems date back to the beginning of the 20th century, and drones have been a growing phenomenon for decades, the Ukraine war is really the first time UGVs have been used to this extent. So, there's no established military doctrine within Ukraine or anywhere else from which to glean best practices. Ukrainian troops say infantry combat planning procedures are applied to combat robots, but coordinating an attack that includes them is more difficult than commanding only human forces. To an extent, according to Matematik, it's a command and control issue. Given the novelty of the technology, the headquarters sends combat UGVs into action without always factoring in their technical limits. They need UGV experts to adjust missions to what the machines can actually do, which complicates planning and raises the bar for officer skills. So during this period, when both crews and commanders are gaining the necessary expertise and experience firsthand, coordinating robots in fast-moving assaults will likely continue to be along a fairly steep learning curve. Still, rapid progress is being made. As Matematik sees it, the problem is that different units have very different experiences and views, so it's hard to bring everything under one standard quickly. You can't do everything at once, but I think that over the next year this will scale up and we'll reach a clear understanding of the standards, who uses ground drones where and how. According to him, combat ground robots are already operating at distances of over a mile from enemy positions and show their greatest value in defensive operations. They support or replace infantry, helping to hold positions with fewer personnel and reducing the risk to soldiers. Arranged in layers, armed UGVs form a dense, hard-to-breach fire system. Large platforms are typically positioned on the second or third line from the zone of immediate combat to protect them from Russian FPV drones, the primary threat to them. Dug into these positions, they act as remote observation and firing points. They can wait there for days without the need for food, water, sleep, or even a quick toilet break, while automatically detecting and tracking targets. As a result, a single operator can control 3 to 4 sectors at once from a safe shelter. However, while such defensive UGV tactics are quite well established by now, the tactics for robot attacks are still taking shape. Offensive operations are far more complex than defensive operations. For now, their most effective role is in reconnaissance in-force operations, where robots advance without personnel to draw enemy fire. During assaults, they serve as a fire shield or escort element, pinning the enemy down. Makar provides a telling example. We planned an operation around ground robots, providing the main fire support for the assault group. It was a comprehensive setup: 2 kamikaze robots carrying Mon-90 mines, a combat module armed with an Mk-19 grenade launcher, and an evacuation platform. The first kamikaze robot blew up the enemy position before the assault started. The second moved parallel to the infantry across the field and, on command, attacked the enemy at the coordinates provided during the fight. The grenade launcher module provided cover in open terrain as our guys were moving in. The robot fired its full ammunition load accurately at the target. Sadly, we lost 1 soldier to artillery fire. As soon as the area was secured, the logistics robot moved in and evacuated the body. This example proves that robots are capable of effectively supporting assaults, destroying fortifications, and manpower before close combat starts. In another famous example, a kamikaze UGV forced Russian fighters to surrender by threatening to blow up their position. Now, Ukraine is also starting to introduce more powerful combat platforms that can carry more ammunition and heavier modules and function more like an infantry fighting vehicle than an infantryman with a machine gun or grenade launcher. These heavy-duty UGVs include the aforementioned Protector and T-700 Browning, both capable of carrying around 1,550 pounds, and the Vatag, which carries up to 4,400 pounds. The T-700 Browning is armed with 2 machine guns, a 12.7mm Browning M2 and a 7.62mm PKT. The Vatag was developed for the 25mm Bushmaster cannon, the same one used by the US-made Bradley infantry fighting vehicle. Its developer says the chassis can even carry an entire 40 rocket load for Grad multiple launch rocket systems. But it doesn't end there. Ukrainian developers are preparing repeaters and platforms to carry and deploy small kamikaze drones, as well as UGV-mounted anti-tank missile systems, man-portable air defense systems, autocannons, and even flamethrower rocket launchers. A fully automated robot army may still be some way off, but for now, UGVs are significantly leveling the playing field in terms of manpower for Ukraine. As Poritsky puts it, "We don't have enough people. The Russians throw their men into the meat grinder. We send robots to the scrap heap. We storm with them, lose them, but swap money and metal for enemy manpower." With Russia and many other nations also leaping into UGV development at a pace, there are likely to be huge developments in this space in the near future. Now, gain more insight with this video on Ukraine's robot army that we recently produced. We'll of course stay on the pulse of developments, so make sure you subscribe to the channel so you don't miss out. Thanks for watching.